So for today, I wanted to take a look at Ryzen Master. So I've got a build with a Ryzen 9 5900X 12-core processor. And Ryzen Master makes it really easy to apply an overclock. So using Ryzen Master, you've got your home mode, your creator mode, your game mode, and then profile 1 or 2. Profile 1 and 2 are kind of your own setup, and then creator mode and game mode are kind of the built-in, baked-in Ryzen Master modes. So in Ryzen Master, we've got a couple of things we can look at. We can have the different modes and profiles on the left. We'll get to those in a minute. And then along the top, you've got your temperature, speed, power, and current. So we're gonna be looking at your temperature, your peak speed, your PPT. So your PPT, or power package tracking, is the power that's being supplied to the socket. So that's measured in watts. So we can see that the stock setting for that on this motherboard is 142 watts. And of course, by default, this is kind of whatever the CPU is rated at, and the motherboard could differ from that a little bit, but there is kind of a stock setting. So right now the 5900X is running at 142 watts PPT. The TDC, or thermal design current, is at 95 amps. So that's the default for socket AM4 for this particular CPU. And then you've got your EDC, which is your electrical design current. And that's gonna be the maximum number of amps that can be delivered to the motherboard and in a peak period of time. So for example, when you first put a load on the CPU, you have a peak amount of current draw, and this is at what point it's limiting that peak to. The TDC, or thermal design current, is the maximum number of amps that can be supplied under normal conditions, under normal thermal loads. So in the home mode, we're literally just seeing a display of your CCDs. So in this case, the 5900X has 2 CCDs, each with 6 cores for a total of 12 cores. You can look at CCD 0 and you can look at CCD 1. And within each CCD, it'll show you which cores are awake or asleep and what speed they're running at. We can see next to our core 02 on CCD 0 that there is a yellow star. So what this indicates is that that is the fastest core for this particular CCD. If you're looking at the little dot, that's your second fastest core. So these are your peak highest performing cores. They're going to boost the highest when boost is enabled. These cores are essentially where all of your primary processing threads are going to want to run. So if you're playing a video game, this is where your world thread should be, is on your best core or your second best core. And then other threads can kind of do whatever. So when we look at CCD1, we've got the same thing. Core 12 is the fastest core of CCD1, and core 8 is actually the second fastest core of CCD1. So what this means are these are your highlighted cores for their capability of having higher boosts and higher megahertz. Now the reason this is important is if you are going to be doing any voltage stepping or reducing voltage on your cores, these cores are probably going to need a little bit more voltage than some of the other cores simply because they can boost higher. So for overclocking using precision boost, the key limitations and limiting factors are going to be your PPT, your TDC, and your EDC. These are the main ones to kind of pay attention to, because when we actually run some benchmarking tests, we can see which of those is kind of hitting its maximum, and those are the ones we need to increase in order to get a little bit more performance out of the CPU. And every time we increase some of those numbers, we're going to see that the thermal load on the CPU is going to be increased. There's kind of a cost-benefit ratio to how much performance you're going to get out of the CPU for how much extra wattage, power, and thermal load you're going to actually have to add. So, you know, a 15 or 20% overclock, probably not a big deal, but if you start getting into like saying using the motherboard's power limits and just completely unlocking it to the maximum ability of the motherboard, that CPU is going to get pretty hot. The CPU will thermal throttle if it goes above its thermal designed limits of about 90 degrees Celsius. It'll automatically start thermal throttling. But you don't want to necessarily just crank it to maximum and let it just thermal throttle constantly. So beneath the CCD listings, you can see your voltage control. Right now in this display, we're just seeing the measured core voltage, the measured average core voltage. We can see that simultaneous multi-threading is on. You can turn this on or off. Under memory control, we can see important information like what your memory clock and your Infinity Fabric clock are running at. You want those to be aligned because a 1-to-1 ratio is optimal for your memory clock and your fabric. And beneath that, you've got some of your different voltage measurements, which we won't have to pay much attention to today. You've got your DRAM timing configuration, so you can see every single potential timing setting on your RAM. And we won't be playing with the RAM timings either. The RAM is actually running CL14 right now at 3600 megahertz, so it's pretty optimal. And then there's a bunch of other information that I won't get into today. Let's get into the creator mode. So in creator mode, right now it's under just default creator mode. And default creator mode, all of the cores are presently enabled. You can actually disable one entire CCD. So in gaming mode, for example, you don't need 12 cores for most games. If you go into game mode, you'll actually see that by default, you have an entire CCD disabled. And that's because having 6 cores that can draw more power, they can run higher boost, you actually get higher gaming performance running less cores because those cores are given a little bit more power and flexibility to boost higher and boost longer. Because now there's only 6 cores drawing power instead of 12. In creator mode, you can obviously switch between the two. And in creator mode, typically, let's say you are a creator and you're doing video editing or some kind of encoding or compiling, you're going to want to be using all 12 cores, so leaving it at 2 makes sense. Now here right now, I can't actually change my peak core voltage, but I can go down to simultaneous multi-threading and turn that off or on. In creator mode, simultaneous multi-threading being on makes more sense. You're going to have the ability to have more threads being processed at a given time, which allows you to complete a workload a lot more quickly. If you have that turned off, for example, a lot of older games or even some benchmarking utilities will actually give you higher scores. Benchmarks like TimeSpy, you can actually get higher scores turning simultaneous multi-threading off rather than having it on. And so really in real world scenarios, leaving this on makes the most sense. And in creator mode, on is the default. Under memory control, if you want to do some memory overclocking, you could play with this. You could say push alt to manual and you can go and play with all your controls. For right now, we're not getting into memory overclocking. We're just going to look at the CPU overclocking, and I'll do a RAM overclocking video down the road. It's a lot more complex of a topic. So in creator mode, we could also go and we could disable individual cores. So like I mentioned before, if you wanted to just disable a couple of your cores and leave only your best performance cores, you could even do something like this, where now it's only a 2-core CPU once we've applied these changes. But in most real-world scenarios, it's going to make sense to just leave all 12 cores running. If you are looking for better gaming performance, running just 6 cores might be making a little bit more sense for you. So in creator mode, those are basically the main settings. Now that's just under your default setting. If we go to Precision Boost Overdrive, this is where we can change these numbers. So if you remember, over in the home side, you've got 142 watts as my stock PPT, 95 is my TDC, and 140 is my EDC. Now, at this point, we're gonna run Cinebench so that I can show you what that load looks like when you have a load applied to the CPU. So now that we have Cinebench running in the background, we can see that there is a 97% load on our PPT limit. We've got a 100% load on our TDC limit and a 100% load on our EDC limit. We can also see that the CPU temperature is not even getting above 70 degrees Celsius. So we've got a lot of headroom to be able to kind of modify and change some of these limits. So let's just say for argument's sake, you wanted to go kind of full send. So you went to creator mode, you went to Precision Boost Overdrive, and you just allowed this to run at the highest limits. So the max PPT limit for this motherboard, which is the Asus Creator ProArt X570, is 395 watts on your PPT, 255 amps TDC, 200 amps EDC. Now that's a lot of power. So in order to apply these changes, what we'll need to do is hit apply. So we're actually 395 watts limit here on our PPT, 255 on TDC and 200 on EDC. So I'm running Cinebench right now with all the power limits removed. And we're seeing that, of course, our EDC, our 200 amps EDC power limit is the main one that we're kind of exceeding at the moment. Now, we can't make that go any higher. So your 200 amp limit is being met. Our CPU is only hitting 80 degrees, so we actually have a lot of thermal headroom available still on our cooler, but we've reached the limit of the motherboard. So at this point we can see that all the cores are running at about 4.3, 4.35 gigahertz, and that's kind of the peak all-core boost that we're gonna get out of this CPU, even with the power limits unlocked. Now we can try a couple of different things here. So for example, I could go back over to creator mode and I can say, you know what, let's disable a couple of cores and see what happens. Now in this case, it's telling me I need to reset. So this is in order to ensure that we can have these cores parked. So in order to disable the cores, we're gonna have to reboot. So I'm gonna go ahead and do that. All right, so now that we're back, I'm running the Cinebench test again with 4 cores disabled, 2 on each CCD. And what we're seeing is instead of 4.33, we're getting up to 4.42, 4.43. And so you'll see that the maximum boost goes up the more cores that you disable. That's just simply because there's less cores drawing power and there's more power available for the other cores. And you can actually see that right now, as far as the motherboard's concerned, we're only using 37% of the motherboard's power limit for PPT. We're only using 35% of the amp limit and current limit for TDC. And we're using about 83% EDC. So right now, there are other limits that are causing these cores to not boost higher, and that's going to be related to the CPU itself and how the CPU is designed under certain workloads to allow boost to go that high. All you really need to do is go and tinker with these values to get better results. And on something like an air cooler, which this is on a Noctua NHD15S, the cooler is more than sufficient to keep the CPU cold. Now my ambient temperature down here is about 18 degrees Celsius. So if you're looking at a hot summer day that's 32 degrees Celsius or 110 degrees Fahrenheit, 115 Fahrenheit in the room where your computer is, your computer's not going to be able to sustain these same kind of peak boosts. If your ambient temperature goes up by 15 degrees Celsius, your CPU temperature will also go up. It's just kind of inevitable. So once you hit that 90 degrees Celsius limit, you're going to start thermal throttling and slowing down. So if we go back into creator mode, we can go back to our CCDs, and we can just re-enable those cores. Probably going to require another reboot. And then we can actually talk about our PPT, our TDC, and our EDC. Now, if our stock PPT was 142, I would recommend looking at which ones are being throttled. So again, in your home screen, you can see which ones are throttling when you're at a full load, and increase them incrementally. I don't recommend necessarily just going to maximum power limits for the motherboard unless you've got the cooling for that. But you could say, if your stock is 142, you could say, well, let's go to 185. If your TDC stock was 95, you could say, well, let's go to 135. And if your EDC stock was 140, you could say, well, you know what, give me 175. So we're just arbitrarily applying some number, and you could be a little more scientific about it. You could say, I'm going to apply a 15% increase to my power limits or a 20% increase to my power limits, and then run your tests, run your benchmarks, run your game workloads or your production workloads, and just make sure that those temperatures are within reason. So here's why game mode's cool, because right now we're running all core 4.536 megahertz, 537, 538, thereabouts. And that is at the stock power limits for the CPU. Now, you'll notice the CPU is hitting 82 degrees Celsius. It's the hottest we've hit in all of the tests so far. And it's sitting there consistently. And that's because the higher these core clocks go, the more power they're drawing and the more heat they're producing. So at all core 4.5, we're actually producing a lot of heat. While there may be some benefit from going into game mode and running only 6 cores for some games, at an all-core boost clock increase, one of the nice things about Precision Boost Overdrive is that you're going to be able to maintain those single core boost clocks. And those are important because your world thread, most games, the game engine itself that dictates all the other threads, your physics threads, any other calculations that go on in the background, simulation threads, your main world thread is kind of still what drives the game. So a good example of that is Stellaris. It's very single core driven. So the faster your one core goes that's assigned to that world thread, the faster the game can run. So in that case, you know, if you were to do just a purely all-core overclock and hard set each core to 4.5 gigahertz, 4.4 gigahertz, and just let it run, you're missing out on the ability to boost to 4.7 or 4.8 gigahertz, which does cut a little bit of performance out of certain games. So the other thing that you can do with Ryzen Master is you can set up your own profiles. Now, Ryzen Master is limited to 2 profiles. Under the individual profiles, you can actually go and save your own settings that you want. So you can say, hey, I want to have CCD0 and CCD1 both enabled, but I want to manually control my individual core speeds on my CPU. So you could go to Precision Boost Overdrive, you could go to Auto Overclocking, or you could go to Manual. Now, Manual, you can go and you can actually type in, I want this to run at 3900 megahertz. Now, you have to be really careful with manually setting your clock speeds. If you set it too high, after Windows loads and Ryzen Master loads and applies the changes, your computer's just gonna lock up. Now, the nice thing is if you've got user account control enabled, which it is by default, Ryzen Master will always pop up and say, you have to run this in order to have admin privileges and elevate its permissions. So when Ryzen Master loads up, you can effectively just say, no, don't run, and it won't crash your computer. If that happens, you have to uninstall Ryzen Master and reinstall Ryzen Master to blow out your profiles so that you can come back and try again. So be careful with the manual overclocking. For example, while these cores are capable of going up to 4.8, if you were to just plug in 5000 and apply those changes, your computer would definitely freeze up and stop working. So you have to be careful because you can't just say, I'm gonna have all my cores running at 5 gigahertz. It doesn't really work that way. You can tell the program to try, but it's not gonna work. So let's say you wanted to do an all-core overclock. You could go 4300, 4300, and you can go and apply those all the way down. Okay, so what I've done is I've applied 4450 to CCD0 and 4350 to CCD1. CCD0 is going to be able to reach higher clock boost speeds than CCD1. That's just kind of a rule of thumb for these CPUs. CCD0 just always has a little bit more performance than CCD1. And so we're also going to need to manually set the core voltage. So we'll do 1.3625 volts. And this is maybe or maybe not stable. A good test to run on this would be Prime 95 or to run OCCT to try to see if there's any errors. They'll actually do error detection. So we'll apply and test to see if we can do this manual overclock. So when we boot into Windows, wait a couple seconds, Ryzen Master is going to auto load. Do you want to allow this app to make changes? Yes. So now when this loads, it's actually going to apply that overclock that I put in. And it's going to test. So right now, I am successfully hitting my 4.45 and my 4.35 all core. And this is a pretty safe bet for 5900X. It's kind of why I chose the voltages and the clock speeds that I did. I could try pushing it a little bit further, but ultimately I wanted to just let it run its stress test to make sure there's no problems with it first. The test was successful. So now I'm going to go run Cinebench. All right, so if we go to home, we can see, hey, look, this is cool. We're getting 4.45 and 4.35, which is exactly what I intended. So now I should go and run some Prime 95 and some OCCT stability testing to check for errors, but it's a pretty safe bet that this is actually stable. The CPU is drawing 163 watts of power, and we're still within the thermal limits that are allowed by the motherboard. So I might say, all right, this is good. Let's see how much farther we can push it. Now I could go 4.65. This is probably where we're gonna get some instability. And again, the purpose of me showing you Ryzen Master today isn't so that you can go in and do what I'm doing. Again, this can be done in the BIOS, or it can be done through Ryzen Master or Project Hydra. But for me, the idea is to kind of show you what you can do so that if you want to tinker with it, you can. But my recommendation is that if you're brand new to this, just go and unlock the power limits for your CPU. Increase your PPT, your EDC, and your TDC by 20-30% increments, and then smaller increments as you go. Just make sure your CPU is running within the thermal limits using Precision Boost, and you've got more performance out of your CPU with really no fuss, no muss. So now we're gonna apply this overclock. Oh, see there, I almost made a mistake. I put 5225. That would crash for sure, absolutely. So here, 4.6, that's probably good. We're probably gonna need a little more voltage. I don't like going above 1.35 volts or 1.36 volts. I will, just for science, go as high as 1.4, but I won't tune anything for higher than about 1.36. So if I apply and test, now I'm actually running Cinebench R23 in the background while Ryzen Master is doing its stress test, which I don't recommend doing, but we'll just leave it for science and see what happens. I'm getting 4.65 and 4.45 at 1.368 volts with very little problem. It seems to be stable. Now it may look stable with these stress tests, and I can't stress enough that different stress tests are going to have different results. Different workloads will have different results. So again, right now with Cinebench running in the background, you'll see my CPU is hitting 86, 87 degrees. If it hits 90, it'll thermal throttle, but I'm still within the power limits of the motherboard, and I'm still under the thermal limits of the CPU. And I'm actually getting much more performance out of this CPU. You can definitely get a little bit of benefit from manually overclocking your CPU, but I will note that our peak core boost now is going to be limited. So if I stop this and I run a single core threaded run, and we'll open up Hardware Info 64, you'll be able to see that the core clocks are now not going up to 4.7, 4.75. They're now going to be restricted and limited to 4.65 on CCD0 and 4.45 in CCD1. So you'll see that on CCD1, cores 0 through 5, I've actually lost 100 megahertz. And that's because doing an all-core manual overclock like I did here essentially ignores Precision Boost and just hard sets those clock speeds to whatever I've set up in my overclock. So what you can see here is that Hardware Info 64 is actually showing these at 465, but if we look at Ryzen Master, these cores are actually going to sleep and only running at whatever speed they need to be running at. So effectively, because I've hard set these the speeds on these cores, I no longer can accurately read the current speeds using Hardware Info 64. Using Ryzen Master, I can see that they're still sleeping, they're still cooperating, they're still going into power saver mode, but again, I've lost my peak boost speed. Now, you could get crazy and you could say, well, you know what? This should be able to boost to 4.8, right? No, this is not going to work. And even if it does work initially, it's not going to apply for long. So, you know what? Actually, I'm not going to do something that I know is going to fail. Okay, so I want to do something that's going to work. So we'll go 4650, 4850, because that's one of our star cores, one of our star players. And we'll leave that at 465. We'll put this one at 4800 because it's kind of our secondary. And we'll apply and we'll test that and see where that lands. And again, depending on what you do, you probably will start running into crashes, reboots. But if you want to use Ryzen Master kind of in a no-fuss way, just go to Creator Mode or Profile 1, go to Precision Boost Override, and just increase your power limits about 20 or 30% over what they are stock. Or again, just let it use your motherboard's power limits, and if you're hitting 90 degrees, you're gonna have to reduce those power limits so that you're not thermal throttling. So we have 485, 4800. So what I'm looking for here is if we can do a sustained 4850 while running Cinebench. So it looks like it's pretty much an instant crash. So again, this is kind of what I was talking about. If you're going in and setting your individual clock speeds too high, you're going to run into issues where you're disconnecting, you're rebooting, you're crashing. And so one of the nice things, and I'm a huge advocate for Precision Boost over Overdrive, because it is essentially going to allow you to overclock and still maintain stability. So you can go and say, increase all my power limits 30%, and the system will maintain its stability on its own. Now, if you're lucky, when Ryzen Master is applied again after a reboot, it won't immediately crash, and you'll be able to go in and change those bad settings that it doesn't like to something a little bit more stable. Okay, so these clock speeds are far too high. So I'm gonna just hit reset profile, and I'm gonna hit apply. And that's just gonna wipe out that overclock that I had, because I don't wanna be using an overclock. So really quick recap, if you're new to this and it's your first time, you've just turned on your computer and you wanna get a little more performance out of it, just go to Precision Boost Overdrive in any one of your profiles and just increase your PPT, TDC, and EDC from stock. So again, if your stock is 142, 95, and 140, just put some reasonably higher numbers, maybe 15 or 20%, depending on your cooler, and test it to see where those temperatures end up. Don't let the temperatures get above about 80 to 85 degrees. Bear in mind that in the summer it's going to be hotter and hotter in the room, so you want to leave a little thermal headroom so you're not constantly tweaking with your overclocks. If you've got a good enough cooler, you can just go Precision Boost Overdrive, let it use the motherboard's power limits, and hit apply. And you're done. You're now getting the peak performance that your motherboard and CPU combination can provide. Just make sure you test it, keep those temperatures not bouncing off 90 degrees all the time, so it's not just constantly thermal throttling. Try to aim for about 80 degrees Celsius for a reasonable overclock and something that's going to give you a little bit more power out of your CPU. So this has been a not so quick overview of Ryzen Master, but hopefully this gives you the information you need to get started out doing some basic overclocking and getting a little bit more performance out of your CPU. Thanks for watching, and we'll catch you in the next video.